Dear students, today we will discuss on diseases of potato and its management. Potato is the most important dicotyledonous source of human food and ranks as fifth major food crop, exceeded only by cereals, that is wheat, rice, maize and barley. This is going to be the future food crop of the millions, especially in the third world countries. However, the full potential of this crop can be realized only if the diseases and pests are kept under the manageable limits. A large array of diseases caused by viruses, bacteria and fungi attack this crop. Now let's discuss about the fungal diseases of potato. First one is the late blight. It is caused by Phytophthora infestans. Now let's see the symptoms of the disease. Late blight affects leaves, stems and tubers. It appears on the leaves as pale green irregular spots. The spots in the beginning are more localized on the tips and margins of the leaves. In moist weather, the spots enlarge rapidly with central tissues turning necrotic and dark brown or black. Often the spots have a purplish tinge. On the lower side of the leaves, a white mildew ring forms around the dead areas. In dry weather, the water-soaked areas dry up and turn brown. Now let's see the management of the disease. First one is the pre-planting management options. Planting of resistant or tolerant varieties. Good drainage and good air movement will help reduce moisture levels in the canopy. Rotations of 2 to 3 years to non-host crops are recommended. Elimination of overwintering inoculum. Planting of pathogen-free tubers. Next is the management in established potato fields. First one is the healing. Soil can be made deeper around the base of the plants after emergence of the young potato plants. Healing helps in early weed control and minimizes tuber infections from sporangia that wash off the leaves of infected plants into the soil. Next is the irrigation. It is important to minimize the time that leaves are wet to help prevent foliar infection. Irrigation should be timed so that length of the night dew period is not extended. That is, no late afternoon, early evening or morning irrigation in order to allow plants time for drying. Next is the fertilization. Excessive nitrogen fertilization increases canopy cover, delays maturity and may reduce yield. And the last one is the fungicide applications. Spray mancozeb at the rate 0.2% followed by metalaxyl at the rate 0.25% or combination of cymoxanil 8% plus 64% mancozeb at the rate of 0.3%. This is about the management of the disease. Next important disease is the early blight. It is caused by Alternaria solani. Now let's see about the symptoms of the disease. The disease starts appearing on potato crop just before tuberization. The lowermost leaves are infected shows brown spots which may be angular, oval or circular and have concentric rings. The disease can be distinguished from the late blight by the absence of white cottony fungal growth. When a spot appears on vein, a part of it gets necrosed. Now let's see the management of the disease. Removal and burning of humps of the affected potato crop. Application of nitrogenous fertilizers up to 200 kg nitrogen per hectare along with recommended doses of P and K significantly reduce the disease incidence. Several fungicides such as Ginep, Diconil, Mancozeb provide good control of the disease. Resistance is available among late maturing varieties. Next important disease is the stem canker and black scurf. It is caused by Rhizoctonia solani. Now let's see the symptoms of the disease. Lesions on sprout tips cause delayed emergence and failure to emerge. Slightly sunken brown cankers of variable size and shape affect stolons and stems at or below the soil line. Cankers may girdle stems and result in aerial tuber formation, plant wilt and death. Now let's see the management of the disease. Because sclerotia are long-lived in the soil, only long rotations with cereals and grasses reduce disease incidence. Shallow planting of well-sprouted tubers reduce the exposure time of sprouts in the soil. Seed tuber treatment effectively reduce seed-borne inoculum when soils are not heavily infested. Trichoderma and binucleate rhizoctonia used as biological control agents reduce severity. Next disease is the Fusarium dry rot and wilt. It is caused by Fusarium species. Now let's see the symptoms of the disease. Dry rot is one of the most serious storage problems. Tubers initially have dark, slightly sunken lesions that later expand superficially, leaving internal cavities that may contain different colored mycelia, depending on the species involved. The margin of the rod is clearly defined. Concentric rings appear on the tuber surface and external mycelium is evident. The tuber dries and hardened. Next is the management of the disease. Use disease-free seed, good water management and crop rotation. Treat cut seed with chemical protectants. So this is about the fungal diseases of potato. Now let's see some of the important bacterial diseases of potato. First one is the bacterial wilt. It is caused by Ralstonia solanacearum. Now coming to the symptoms of the disease. Initial wilting may affect one side of a leaf first or one branch and not another. Mild yellowing usually accompanies wilting. Later symptoms are severe wilt and browning and desiccation of leaves followed by death. Vascular strands darkened and when a cross section is made, a greyish white slime exudes, except in mild cases. This can be confirmed by the flow of milky white strands from a stem section placed just below the surface of a glass of still clear water. This is about the symptoms of the disease. Now coming to the management. Crop rotation is most effective with the potato strain race 3, but difficult with race 1 that also affects many other crops and weeds, especially Solanaceous. Disease seed causes the most severe bacterial wilt infection and results in spread to non-infested soil. Spread also occurs via water flowing along rows and from field to field. Soil survival in crop debris or survival free in soil varies considerably, usually 1 to 3 years for race 3, often longer for race 1. Self-sown tubers can increase survivability as can growth in the rhizosphere of some crops and weeds. Next disease is the black leg and soft rot. It is caused by Arruinia species. Now coming to the symptoms of the disease. Black leg can occur at any stage of development when moisture is excessive. Black slimy lesions most often progress up the stem from the soft rotten mother tuber. Yellowing and upward rolling of leaflets may occur, often followed by wilting and death. Affected tissues become wet and cream to tan colored and soft and are easily separated from healthy tissue. Now coming to the management of the disease. Avoid planting in wet soils and do not over irrigate. Harvest tubers when ripe, handle them gently and do not leave them exposed to sun. Tubers must be dry prior to storage or shipping. Next disease is the common scab. It is caused by Streptomyces scabies. Now let's see the symptoms of the disease. Several types of lesions developed. They may be superficial or reticular, deep or pitted or protuberant. They vary in size and shape but are usually circular and not more than 10 mm in diameter. They may coalesce so that most of the tuber surface becomes affected. Fibrous roots may also be damaged. Now coming to the management. Maintain high soil water levels compatible with good potato growth during tuber set and enlargement. Avoid planting scabby seed tubers. Avoid repeated crops of potato or other scab susceptible plants such as red beet, sugar beet, radish, rutabaga, turnip, carrot and parsnip. Scab resistant varieties are useful. Maintain soil pH levels at 5 to 5.2 with acid forming fertilizers or sulfur. Avoid heavy lime applications and preferably use dolomitic lime where needed. This is about the bacterial diseases of potato. Next we will discuss some of the viral diseases of potato. First one is the potato leaf roll. It is caused by potato leaf roll virus. Potato leaf roll virus is the most important potato virus and is common in all countries. Yield losses is highly susceptible cultivars can reach 90%. Now coming to the symptoms of the disease. Primary symptoms are rolling of upper lips, especially of leaflet bases. These leaves tends to be upright and are generally pale yellow. Tubers of highly sensitive cultivars develop net necrosis in the flesh. Secondary symptoms are rolling of basal lips, stunting, upright growth, and paleness of upper lips. Roll lips are stiff and leathery and sometimes tinge purple on their undersides. Rolling of lower lips is usually lacking. Natural transmission is by aphids in a persistent manner and through infected tubers. Now coming to the management of the disease. PLRV can be controlled by selecting healthy plants and eliminating diseased plants through roguing in seed propagation. Systemic insecticides will decrease spread by aphids within the crop but will not prevent infection by virulliferous aphids from other fields. PLRV is the only potato virus known to be eliminated from tubers by heat treatment. Resistant cultivars have been developed recently. Next disease is the potato virus A and Y. It is caused by potato virus Y and potato virus A. Potato virus Y is the second most important potato virus. It is perpetuated through infected tubers and transmitted by aphids in a non-persistent manner. Yield losses may reach 80%. Now let's see the symptoms of the disease. Symptoms vary widely with virus strain, cultivar and environmental conditions. Rugosity, bunching, twisting of leaves, downward turning of leaflet margins, stunting, necrosis of leaflet veins, necrotic spotting, leaf necrosis and stem streak are typical. Less sensitive cultivars may react by developing with only a mild mosaic, or they may be infected symptomlessly. PVA is in many respects similar to PVY. When present in certain cultivars, it is generally less severe than PVY. Yield losses may reach 40%. PVA causes mosaic as well as rugosity and crinkling, and leaves may appear shiny. PVA symptoms are usually milder but cannot be easily distinguished from those of PVY. So this is about the symptoms of the disease. Now let's see how to manage this disease. Control of PVY and PVA is by clonal selection and roguing of seed propagation. Resistant cultivars are available for this disease. Next disease is the mosaics. Several viruses are involved for the mosaics in potato, that are PVX, PVS, PVM and also both PVY and PVA. Infection may be mild in some cultivars and is frequently latent. Virulent strains may cause crinkling. Some cultivars are hypersensitive to certain strains and react with top necrosis. PVS is common and may cause mild symptoms. It has little effect on yield. It is transmitted through infected tubers, by contact and by aphids in some strains. Infection is normally latent, although some cultivars react with mild mosaic or faint vein banding. A few sensitive cultivars react with severe bronzing, necrotic spotting or even leaf drop. PVM is less common than PVY, PVX or PVS, and little is known about its effects on yield. It is perpetuated by infected tubers and transmitted by contact and by aphids. The virus is latent in some cultivars, although in others it causes a mild mosaic or even a severe mosaic and leaf crinkle. Under certain environmental conditions, sensitive cultivars may also develop necrosis of petioles and leaf veins. So, these are the symptoms of the disease. Now coming to the management. PVX, PVS and PVM are controlled by clonal selection during seed multiplication. Rogging is useful only when obvious symptoms develop. Cultivars resistant to PVX are available. So far we have discussed about the different diseases of potato caused by fungi, bacteria and viruses. Now coming to the conclusions of this topic. Potato is affected by many diseases like late blight, early blight, wilt and also so many virus diseases. Timely application of the control measures such as prophylactic measures can manage the foliar diseases. The soil-borne diseases are difficult to manage. So for this, a holistic approach with proper soil treatments with chemical and bioagents is necessary. Viral diseases can be managed by opting virus-free planting materials as well as timely controlling the insect vectors.